Hey guys, Rev from Into Gaming. Today we're going to do a quick blueprint interface interaction demo slash tutorial. We're going to set up interactive drawers. It's based on a UE forum post asking for help. So here we go. First things first, we're going to create a blueprint interface. BPI demo. Name this what you like, but you should prepend it with BPI, so it's easier to look up. Anyway, in the blueprint interface, you're going to get a new function. You want to name it. You can name it interact if you wish. I'm doing this one as demo interact, and that's it. That's all you have to do in that class. So next thing, in your character class, you want to set up a line trace. So I'm using the F key. If you have an input action already bound in your project settings for interact, you can use that. Use that if it's not already bound to something else. If you already have logic bound to the input interaction key, then don't do it until you verify everything's working. So use a empty key, like I'm doing here. Take in the camera, get world location, and we're going to do a line trace here. So world location is the start. We're going to get for vector and vector times float. Let me zoom in on that. Vector times float, doing 500, so 5 meters from camera position forward. We're going to add that to the world location, vector plus vector, and that will be our end. Visibility channel is what we're using. Actors to ignore, make an array, self, and for debugging I do for duration and draw time is 5 seconds. We're going to take the hit result, break it off that actor, off the hit actor. We're going to does implement interface, and we're going to put in our interface BPI demo and hit the branch. Off that, again, we're going to take the hit actor and we're going to set up some reroutes so we can go and call demo interact, which is our BPI demo message. Done. So basically, what we're doing here is we're line tracing, hitting an actor. If that actor implements our interface, we know it's going to have demo interact set up. So we can call that event. Compile and save. Character aspect of it is done. Next, we want to create a parent class of actor for our drawers. I say parent class because this particular class will be used for every drawer that you have in your game world. It could be a desk drawer, file cabinet, etc. We're going to set it up till we can use any type of drawer in this, and all we have to do is create a child instance for the particular actor we want to set up. So if we're setting up a desk, we're going to have a child actor class for desk drawer small, desk drawer wide, etc. Or actually, you just set it up desk drawer and just swap out the message. But we'll go real quick. We're going to do a scene component. By default, we have a scene component, but we're going to override it. And the reason why I do this is because I don't like that stupid ball, that sphere. So boom, done. We still have a scene component in if we need it, and we're good to go. Next, we're going to add a static mesh. This will be your drawer. Rename this the mesh. Keep the naming simple. And then the last thing I want to do is add an arrow component. I typically don't use these on mine, but they're good for tutorial and new users to understand direction of flow. And I will get more into that as we move forward. That's a good color. I'll change this to 0.25 so it's not obstructive. We're going to move it out a few centimeters and then attach it. So it's bound to the mesh. So if the mesh moves, rotates, whatever, the arrow sticks with it and so forth. So that's pretty much it for the components. Next we need to add variables. Closed. Get that question mark in there. Closed. Compile it. Default value is true. Compile it again. Next variable is move distance, and this will be a float, and we want this one instance editable, and we're going to set up a category for it called config, and the default value I want to do on this is just a minimum 10 centimeters. Alright, two more. Let's see, closed location, and that needs to be a vector, and then we're going to make another one, opened location. Alright, and these will represent our position when the drawer is closed. So when you set up your static mesh, you attach it to, you position it onto the desk. For example, you position the drawer on the desk and you want to have it in the closed position. That's going to be the default. And then opened is where it's going to move out to when interacted with. Okay, that's that. Next thing, we want to go with our begin play. And we're going to set our closed position. Pull this out. We're going to get relative location. Oh, I gotta get to my mesh. Sorry. Trying to breeze through this pretty quickly. Get relative location. And we are going to attach that. So now on begin play, we're setting our closed position. Wherever its relative location is at begin play, that is the closed position. So off this, we want to split here, and then we're going to get our open location. Come on, attach. Sometimes we're going to set it. Sometimes it just wants to be weird. Set, and we're going to split this. Connect Z, connect Y, and here we're going to add float by float, and then we're going to take our move, and then we're going to take the output in here. So what we're doing here, let me get over in the viewport to show you this, and let's go with the right position. Select the mesh. So basically what we're doing with the drawer itself is we're going to lerp it based on a vector position, its relative location, and we're only going to move it on the X. So X is this way. So closed position, open position, closed, open, closed, open. We're never going to move up on the Z, and we're never going to move right and left on the Y. So the only axis we're dealing with is the X. So the difference between closed and open is just an X coordinate change. That's it, an X vector value change. So, and the move distance is the length of the drawer and so forth. And you will see that when we start finishing up. So for the most part, that right there is it for begin play. Now we need to add our interface. BPI demo. So now this actor and the character can communicate back and forth with the blueprint interface without having to do any casting. And when we add this interface, we have demo interact, right click, implement event. Now we have the demo interact event set up. So from here, we need to pull this out. This is our state. We want to branch that. So basically what we're asking here is when this is triggered, when the event is triggered, is the drawer open or closed? By default, it's closed. And from here, we want to do a timeline. And name this one open, close. So if we're closed, we want to open, so thus we play, and then the update will open the drawer. If it's false, we want to reverse, which will close the drawer. So let's get into our timeline. And we're going to do a float, a float track, so keep it very simple. Name it alpha. And our length is going to be 0.5. And we're going to add a key and add a key. First key is 0 and 0. Second key. Second key, 0.5 up here. That's the length. The total length of time is half second. So our value here needs to be 1, but our time needs to be 0.5. And we're going to pull this out. So we got 0, 0, and then we have 0.5 at 1. So both selected. Right click on one of them, hit auto. We're going to add a nice curve to it. Now our track's got a nice smooth, so it has an acceleration and deceleration applied. Nice and smooth, so we're done with that. So out of update, what we're going to do is take the mesh and we're going to set its relative, spell it right, relative position or location. And clean this up a little bit. And what we're going to need to do here is we're lerping on vector. Vector to vector. I'll go ahead and pull this down a little bit. We're going to lerp the closed position to the open position. And we're going to do based on alpha. And let's straighten that up. So on play, which is going to be going from close to open, we're taking the closed position and we're going to lerp to the open position. On open to close, we're hitting the reverse, so it will be open to closed. That simple. Last thing we need to do is set up our state change. And we do that by seeing what the current value is and modifying it off. So if the door is closed, true, we want to set it as open. So open, which would be a closed false value. If we want it, if it is not closed, we want it to set it to closed. So this would be closed. Simple. So basically all we're doing, we're changing the state once we're finished, so the next time we interact, we know we have reset this to what it should be. We get the interaction. So that's it. That is 100% of the code that's needed for this. The only other thing that I want to do in this is change set the class as an abstract class, so you can't drag and drop this particular parent class into the world and use it and so forth. You have to make a child instance. So with that, right click, create child blueprint class, and we're gonna just name this one desk drawer. I can spell desk drawer. Open this, and for the mesh, I have some simple little static meshes. I'm going to go to the top, orthographic, and I'm going to slide the back so that the face is dead on with the Y, and then I'm going to go to left, and I'm going to adjust it up, and then I'm going to take my arrow class, or arrow component, and I'm going to move it forward to the front face. So this is our end result. I'm just getting it all nice and lined up. Next thing, I want to go to class defaults and take my config, my move distance, and say 20. So, I mean, if we go top, we can see, let's check that, 10. So 10, 20, 30, 40, 50. So if I want to move the drawer out to this point, I would set 40 centimeters. So the drawer is going to slide 40 centimeters. And that'll be it. So from there, we just got to test it out. Just do a mock-up here. And that looks good. So we have a nice little cube to add. And we're going to take our desk drawer, we're going to drop it on the ground, and see it. See that arrow? This tells us which way the drawer is going to move. So we'll rotate it 180. Now I can take that drawer, lift it up, change this back to 5, and I don't want it flush. I want that little 5 pixel kicking out. And I'm going to move it up. And there we go. We have a desk drawer. And if we wanted to adjust the draw distance off of that, the move distance, we could just change it right here. So I'm going to duplicate this, slide it over, and there we go. We have a second drawer in there. Let's test this real quick. Walk up, hit my F key, in and out, in and out, in and out. There we go. So let's add another one. New child, and we're going to call this wide drawer. Go in here, take the mesh, and add this one. And I'll go to the top. Make sure I get that aligned. And go to left. That align arrow. Component, move that out. And gotta go to class defaults. Class defaults is this one's a little bit longer. So let's change this back to 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I will say, let's move this one out 90. So we have 10 centimeters still inside. And then I will back out up here, drop this one, rotate, save. Oh yeah, change that to 5 so I can little lip, little lip on that. There we go. Boom. Totally different class. Come up. F. Oh, did I not add the right one? That's yeah. I knew something was funking with that when I did this. There we go. Now we get that big one. And while I'm here, just show you this real quick, because this is the mesh itself is just a simple mesh. It's not like a real drawer here. We can do some pretty crazy things with it. I can scale this out and make it actually a big drawer. And I'll just say that I only want it to come out 60. Still a drawer, still running off the class. So that's it. It's pretty straightforward. And doing the child classes, I mean, you could technically I could technically go into this one, click mesh, and then change it to, let's see, draw, and change it to the small, or the small one. Change it to the small one, and then reset the scaling on it, and then boom, and have the same kind of setup with it. Not a big deal. It still works, but preference wise, see, it's got that crazy draw distance on it still, so we'd have to go in here and knock this back down to like 30, play it, and hit it. So I mean, you can swap out the meshes, but it's kind of generally preferred to just do a new class for a specific type of drawer. So desk drawer, you'd have a desk drawer, and then for file cabinet, you'd have another actor, child actor for the file cabinet drawer, and so forth. But that's it. Go back to this and give one more highlight on this, and that is pretty much it. Nothing else to really say about it, and we'll look back at this code real quick. This is the interaction from the character side of it. One thing I do have to note on this is technically I have two cameras, first and the third, so I can toggle. And because I can toggle, and I don't want to have to go through, hey, which camera is currently using if conditional logic every time I want to use the camera, I have a variable called current camera, which a function says every time I toggle, it just resets, it sets the current value on that camera for me. So, but what I want to note is if you're using a third person camera, that camera is behind the shoulder, it's going to be further away than what a first person camera. First person camera is usually in the face of the mesh, real close to the character's head. So this distance would have to change if you're using a third person camera. So be cognizant of that. So if I'm using the third person camera, I want to look at that spring arm, the camera boom length, and let me see what it is on mine real quick. Target length is 300, so technically if I was using that, I mean that it would only go 2 meters past my character. So I have to add the target length value if I want that same 5 meter distance of interaction. So for my character out 5 meters of interaction, I have to add that target arm length as well. So that value would be 800 if I'm using third person camera. So be cognizant of that. So hope that makes sense. If you have any questions, hit me up in the comments. Be glad to help.